So here we have to verify the Stokes theorem for the function f equals to yi plus zj plus xk, where s is the upper half surface of the sphere x square plus y square plus z square equal to a square, and c is the bounding curve. C is the bounding curve. Let's first draw this surface of the sphere, upper half of the surface of the sphere. Let's draw this first. So this is the sphere. This is the sphere, hemisphere, the upper half surface of the sphere, and C is the bounding curve. C is the bounding curve. So we have to prove that del cross f dot nds equals to f dot df. Supposing over here n is outward, n lies in outward direction, right? On this surface, suppose n lies in this direction, then can you tell me in which direction an observer with his head in outward direction on this, at this point n is this. So can you imagine if you have an observer with his head lying in this direction, in what direction he should walk, whether he should walk along this or in this direction, so that he see the whole hemisphere on his left. Obviously he'll walk in this direction. So for this n, for the outward n, this direction of your orientation, this orientation of the bounding curve is positive. This orientation of the bounding curve is positive. For an outward n, this orientation of the bounding curve is positive. So now we have to evaluate this, and we have to evaluate this separately and verify and make them and see whether they are equal or not. We have to verify them, as we have to, so that they are equal. First of all, let us calculate this del cross f dot nds with n lying in outward direction. So you can use the method that we saw in Gauss theorem. Say if this is S, now suppose I add another surface S dash and consider a closed surface sigma consisting of S and S dash. In that case, the integral of surface integral of del cross f dot nds over sigma is going to be, according to Gauss theorem, this theta is going to be 0, and since surface integral on sigma is equal to surface integral s plus s dash, which is 0, this will give you an idea. S is minus of s dash, so this will be del cross f dot nds on s dash. So on s dash, see, on s dash your n is an outward drawn, so n is minus of k, so n is minus of k, and ds is dx dy. So let's first calculate del cross f. We have to evaluate this, so let's first calculate del cross f, right? This will be equal to del cross f is equal to I j k z, this is y, z, x. So this will be equal to minus I and this will be minus j and minus k, minus I minus j and minus k. So the integral ds equals to minus of Now what is del cross f dot n on S dash? It will be minus k dot minus of k, that is 1. It is 1. So this will be minus of ds, which will be, for this case, what is the area of this surface? Area of this surface is minus pi a square. So the surface integral is minus pi a square. Now we have to calculate the line integral with the orientation in this direction, right? If we calculate line integral, let's now calculate the line integral and show it to be minus pi a square, right? So line integral will be yi plus zj plus xk dxi dzk. So this will be y dx z dy and x dz. See, this curve is lying in xy plane. The curve lies in xy plane, right? This is the curve. X square plus y square equals to a square. So on this curve, your z is 0. So obviously your dz will also be 0. X is a cos theta and y is a sin theta. So this will be equal to a sin theta and dx is minus a sin theta d theta. Alright, so rest of it, z is 0, dz is 0. So finally what you get is a square sin square theta d theta, and theta varies from 0 to 2 pi. So this will be minus pi a square. Hence I can say that del cross f dot nds on the surface S equals to line integral f dot dr on its bonding curve. Alright, so this is how this can be done. Now let's move on to next question.